Welcome back. So just now we have computed. I said that default frequency for 8051 is 11.0592 and it is divided by 12 by timer circuitry. Further, it is again divided by 32. It is into 10 power 6. So this will gives us around 28,800 Hz. This is the frequency applied for UART module. Okay, to get this value, actually, we are using that odd figure, whatever it is, 11.0592, because all the serial communication modules will have a baud rates like this. The data rates like 110, 300, 600, 1200, 2400, 4800, 9600, 14400. Okay, so to have these baud rates, actually, this is the main figure. Okay, the clock. When I have this, when I divide it by 2, I can get a baud rate of 14400. Okay, so that is this baud rate 14400. Okay, from which you can easily get the other baud rates 9600. That can be, I can get it by divided by 3. Earlier we have divided by 2. So by 3, by 2, by 4. So all the baud rates I can easily get by using the value that is 28,800. This is the magic figure. Okay, 28,800. To have this value, we are using that odd number frequency 11.0592 megahertz. Okay. So come back to the formula. What is the baud rate to be generated? Okay, so this is clear that UART module is dividing. So your UART is dividing F oscillator by 12 into 32. Okay, so which is giving us 28,800 Hz as a UART frequency. This is the operating frequency for your UART. Okay, so as per UART module, for every one clock interval of this, for every one clock pulse, one bit will be shifted out. That is what a transmission means. Okay, so during transmission means data is transmitted as a start bit first and then 8 further data bits starting with LSB first and then a stop bit. Okay, so transmitter interrupt flag will be set once all the 10 bits have been sent. Each bit time interval is inverse of the baud rate frequency. Okay, see, if I want to operate my UART at a baud rate of 9600, let us suppose I want to have a baud rate of 9600, assuming it as F baud, which is equal to 9600 bits per second. Okay, so 9600 bits I want to transmit in 1 second, right? In 1 second interval, I want to transmit 9600 bits, right? So what is your baud rate clock? Okay, nothing but for one bit, how much is the time interval for one bit? In 1 second, 9600 bits you want to transfer, then it will become 9600 bits per second, right? So for one bit, what is the time interval? That is your actual baud rate clock. At that rate, your UART has to be operated. Okay. So though your UART operating clock is 2800, you want to now get a baud rate clock. You need to do some operation to this your clock in such a way to achieve your baud rate of 9600. That is what uh, the formula for baud rate. Okay. See, if your desired baud rate is 9600, means in one bit rate, in one second, 9600 bits you are transmitting. So, what is each bit interval? Each bit interval will be 1 by 9600 only, no? Right? So, each bit time interval is 1 by 9600 second. Am I clear? So, 1 by 9600 second. Each time interval. Okay. So, for every this interval, one bit have to be shifted out. Am I clear? So for every 1 by F baud, this is F baud only, no? 9600, that is what our desired baud rate. So for every 1 F baud interval, one bit has to be shifted out. Okay? Am I clear? So our desired time interval is 1 by F baud. Okay? I want a clock that will give a time delay of 1 by F baud interval. So for every 1 TD, 1 bit have to be shifted out. Okay. So how to generate this TD? Means your UART should be sample the bit and sent out for every 1 TD interval. Okay. So UART needs a clock whose time interval is TD. For every TD, UART needs to send out 1 bit. Okay. So to give that TD, we are using timer 1 in mode 2 of operation. Okay. Right. This is important for serial communication to operate at a desired baud rate. It needs a baud rate clock. The baud rate clock is generated by timer 1 in mode 2 of operation, which is nothing but 8-bit auto reload mode, right? Okay. So if you want to program serial communication, you have to program timer 1 in mode 2 of operation for the desired baud rate. Okay. So what is the formula for mode 2 of operation? You know, it is FF minus initial count plus 1, which is equal to desired time delay into F oscillator by 12. Is that right? Okay. So you want to now compute your IC initial count to be loaded in a register. Which register? TH1. Okay. For the baud rate, for the desired baud rate, TD is how much? Your TD is equal to 1 by F baud. And F oscillator is 11.0592 megahertz. Okay. Right. Then after substituting these things here, how will be the final value? FF means 255 minus IC, 255 minus initial count plus 1 is equal to, what is TD? It is 1 by F baud into F oscillator by 12 is actual clock given for timer 1. But with respect to UART, actual clock is F oscillator by 12 by 32. So that is nothing but 28800 that we have already computed. Okay. So irrespective of this value, now we will be taking F oscillator by 12 by 32. Okay. So that is this value. So by which I will be getting the formula, which is F baud is equal to 1 by 1 in the numerator, which I have 28800 by this value. 255 minus initial count plus 1, which is nothing but 256 minus initial count is loaded in a register TH1. Okay. Right. This is the formula. So when I vary the value that is loaded in TH1, your baud rate can be varied. Okay, F baud can be varied. Not only this, we have one more bit called S mod. One more bit which is we have S mod, right? Mode specifier bit, which is available in PCON register. That varies the baud rate here. This significance is also in baud rate. So after adding S mod, your actual formula is this one. Okay. So F baud is equal to 2 power S mod into 28800. This whole value is actually 28800, right? F oscillator by 12 and by 32, which is equal to 28800 minus 256 minus TD1. This is the baud rate formula. So if S mod is equal to 0, if S mod is 0, 2 power 0, which is 1, nothing but your F baud is 28800 by 256 minus TH1, right? If S mod is 1, then 2 power 1 is 2, right? 2 into 28800 by 256 minus TH1. That means if S mod is equal to 1, it doubles the baud rate. If S mod is equal to 0, it is a normal baud rate. Okay. And anyway, wherever TH1 is there, it is a variable baud rates. Okay. For different values of TH1, your baud rate can be varied. Okay. So what are the values? Let us suppose if I have taken TH1 as 255. Okay. So if my TH1 is 255, how much? 256 minus 255, because in TH1 maximum that you can load is FF, no? Right? So 256 minus 255, which is equal to 1, and assuming my S mod is equal to 0, then your F body is 28800. Okay. So if your TH1 is 254, then denominator will be 256 minus 254, which is 2. Then 28800 by 2, which is nothing but 14400. Okay. So likewise, we have different value, different baud rates. When I use TH1 in your formula. So that mode 1 is called 8-bit UART with variable baud rate. You can vary the baud rate by varying the value in TH1. Okay. These are the register values for different baud rates. When I load 253, which is nothing but FD in hexadecimal, it can be considered as -3 because it's a negative number, right? Either -3 or in unsigned case, this is 253. I can achieve 9600 baud rate if S mod is 0. Okay. For the same value, for the same FD value, if your S mod is 1, I can have a double the baud rate, 9600 into 2 into 2. That will be 9600 into 2. How much? 96 into 2. 19600, right? 9600 into 2. 19200. 19200 is the baud rate. Okay. If S mod is 1. Similarly, if my TH1 is FA, which is nothing but 250, then my baud rate is 4800. For the same value, if S mod is 1, I can achieve a baud rate of 9600. Okay. So likewise, for the given baud rate, use this formula to compute your initial count to be loaded in TH1 register, uh, right? By which you can start your baud rate count. Okay. Now, similarly, when I come with mode 2, which is 9-bit UART, but it is a fixed baud rate. 9-bit UART means data bits are 9 with one start bit and one stop bit. Total 11 bits are transmitted. When I come for mode 1, It is 8-bit UART, right? It is 8-bit UART with one start bit, 8 data bits and one stop bits. Total 10 bits will be transmitted, out of which 2 bits are overhead bits. Actual data bits are 8. Okay, out of 10, 80% is actual data, 20% is overhead. Okay, so in mode 3, 11 bits are transmitted. So actual overhead is 2 by 11. Okay, 2 by 11 is overhead. Actual data bits are 9 by 11. Okay. And coming to baud rate formula for mode 3 is F baud is 2 power S mod by 64 into F oscillator. Okay. When I take S mod 0, then the baud rate is F oscillator by 64. If S mod is 1, the baud rate is F oscillator by 32. There is no term related to TH1 here. So it is fixed baud rate. You can't vary the baud rate because F oscillator is fixed, which is 11.0592 megahertz. So F baud is fixed. Okay. When I have mode 3, which is 9-bit UART with a variable baud rate, only the formula with the 256 minus TH1 will be added. You have a flexibility to vary even in mode 2. Okay. So that is about serial communication. So now we shall proceed with the problem 1. You are supposed to write an ALP. Of course, you have to write both in high level also. To transfer the message with the 3 characters YES serially at a baud rate of 9600 with 8-bit data and 1 stop bit. This is how the specifications are given for your UART, by which you have to configure the UART module. Okay. So as per the specifications, you have to write ALP, of course. 3 characters you have to transmit serially with a baud rate of 9600 and an 8-bit data, 1 stop bit. So data is 8 bits, okay, and baud rate is 9600. So you have to operate your UART in which mode of operation? Where 8-bit data transmission, 8-bit UART. So mode 1 of operation, okay. So you have to operate your UART in mode 1 of operation. Excuse me. Okay. So as per the given specification, your F baud is 9600 bits per second. And 8 data bits with 1 stop bit. Okay. So you need to operate your UART in 8-bit UART mode. So nothing but this belongs to mode 1 of operation. So the first step is calculate. Anyway, I think it's there in the slide. So the first step you have to calculate timer 1 count to initialize with the required baud rate. Okay. So for 9600, what is the value to be loaded in TH1 register to have this much baud rate? 9600 baud rate. Okay. As it is mode 1 of operation, the formula is F baud is equal to 2 power S mod into 28800 by 256 minus TH1. Okay. So substitute all the values. F baud is 9600 and assume S mod as 0. Okay, assume S mod as 0. So then 2 power 0 term we can delete, and by 256 minus TH1. Okay. So what is 256 minus TH1, which is equal to 28800 by 9600. How much is this? This is around 3, right? 96 3 times. Okay. So that your TH1 is equal to 253. Okay. So by which you can calculate the timer high byte count to be loaded to generate your baud rate clock for 9600. Okay, that's your first step. And next, you have to initialize T mod in mode 2 of operation because we are using timer 1 in mode 2, right? So for that, T mod you have to initialize. So what is the value for T mod to initialize timer 1 in mode 2? Okay, that is nothing but 20H that we have seen already in the timers. And next load that value. Anyway, we will load TH1 with 253 and the fourth step, start the timer to run. Next step, your timer run bit. This should be 1. Then it will start generating baud rate clock. Okay. So these first 4 steps related to baud rate clock generation by using timer 1 in mode 2 of operation. Okay, these things you have to do. And next step onwards, start with our actual serial communication. You need to initialize SCON to select its mode of operation. So SCON format, serial control register format, that is SM0, SM1, SM2, REN, RB8, no, TB8, RB8, sorry, it is 8, RB8 and then TI. RI. So these are the bits, right? So out of which that we can configure in mode 1, Kabatti SM0 is 0 SM1. This is not used and REN receiver enable. At that instant right now we want to transmit, so I will make my receiver disabled. And these are not used bits right now. They can be 0. So by which your value it is comes with 40 hexadecimal value. Assuming SM2 also 0, I can get 40H in SCON register. That is your fourth step. And next, copy the character in S buffer, which itself will start transmission. So how the transmitter is started? By loading a new value in S buffer will start the transmission. Okay. How the reception is started? By clearing the RI flag will start the reception. Okay. So you will load for fifth, next step, load S buffer. Okay, that will initiate the transmission. And then next wait for TI flag. This will say that the transmitter is completed. Then only you can go back to step 5 for loading again the new character. So once you have wait the TI flag, then what you have to do, you need to it is clear that you have completed the previous transmission. So now CPU will load the S buffer with the new flag and then it will clear the TI flag. That you have to taken care. Okay. So what you will do, we will clear TI flag and then we'll go to step 5 to repeat. If you have so many characters, you can repeat it by loading S buffer. Okay. So these are the simple statements to configure serial communication, mainly transmitter. Okay. In mode 1 of operation, UART mode. Okay. So we shall execute this through our keel now. Okay. So take a new project. I'm considering is UART 8-bit mode is my project with the target 8 Atmel 89C51 as my target. And right now I don't want startup file because I wish to write it in assembly. Okay, so here ఇప్పుడు కొత్తది వచ్చిండొచ్చు ఫోన్ ఇవ్వకు నువ్వే చూసి చెప్పు So we will start anyway with org 0 and steps. So the first step is calculation steps. Next, from second onwards, loading steps will come. So the second is T mod. Your T mod should load with value. Sorry, your T move T mod comma hash 20h. And then load th1 with value hash 253, right? And then set the bit PR1. So till here, I can get a baud rate clock of 9600 baud. After that, I have to load your SCON register with the value 40H. So that makes my UART operated in 8-bit UART. Okay. After that, I have to load my character, right? So load a character. S buffer with first character Y. Okay. So as it is a character and it is an immediate value, hash is mandatory. So then you have to wait for a TI flag. Okay. So the bit is jump on no bit. The bit is a TI. If the bit is 0, you should in wait only. So the label is next. Next will be here. Okay. So once you have completed, means when the next step, if the control is coming, means TI is set. TI is set means the previous character transmission is completed. So you can send a new character. So before sending new character, I have to clear TI and then load a new character. So nothing but these 3 steps have to be repeated for how many characters are there in your list. Okay, or else you can put this in a loop properly that you can try on your own. That's all. I learned my transmitter. Okay, right? So save this. Okay, with extension ASM, and then add that file to my group. So then try to compile. So there are errors. What is that? Define already defined label. Okay. See, already next is used label, right? You need to use some other label. Okay. So now save and then now compile. There are no errors now. Build it. Rebuild all and go to debug. You're transmitting out, right? Okay. So in Keel, how can you observe that the characters are transmitted? Um, like your view, you have serial windows in UART. Okay. So if you run this, whatever are the characters that you have sent, the key will captures and it will display on the UART module. Okay. Since we are doing simulations, the sent characters are captured and those are available in a UART module. Okay. You can try out with your own text, right? Is that clear? Any doubt in this program? Yes, I want reply. You have to practice this on your own. This is in assembly. Now we will see the same in C. Okay. So now take another new file. We start writing this in C. So in C, we will include origin 51.h, right? And then our main. So what are the statements here that we will write it in high level now? So the first statement, move T mod, right? So T mod is equal to 0x20, and then TH1 is equal to 253 in decimal, and TR1 is equal to 1. Okay, so this is the baud rate clock, and then SCON is equal to 0x40. Okay, and then this is the transmitter. After that, we have loaded our Y. Okay, so now your S buffer is equal to X buffer is equal to R value. It is okay. I'm giving different value. Okay, so then you have to wait till Ti is equal to 0. It's a semicolon. So if Ti is 0, we are in that loop only, which doesn't have any statement, but it is waiting. Once we come out, then your Ti should be 0. Okay, so these are the statements to be repeated for the next set of characters. Okay, so I'm giving, okay, that's what my main closes. You can make this very simple more by defining a function. You can call that function for a different character in S buffer. But for simplicity, I'm writing this. You do that simplification. Now it is UART C. I have extended with C. Now remove the ASM file, add the C file, and also add startup file. Because for working with C, I need startup file. Is this the file I'm here? Yes, this is the file. Now build your code. Zero errors, zero warning. Build or go to debug. Okay, so now this where your UART one. Now when I run, uh, this is getting continuously. We have to stop the execution. So what I will do for C, this is mandatory while of 1. Okay, so only one time I can get that thing. So when I run the code, one time I got my output CPN. Okay, so this is what uh, serial communication UART programming in mode 1 with 8-bit UART mode. Okay, so one more thing here we need to make clear. What about S mod bit? Okay, so S mod bit, which is the most significant of peak on register. By default, on reset, all the registers are 0 cleared. So S mod bit is 0. By default, it is 0. If you want to make the bit different, then program peak-on, load the peak-on, whole register you have to load because it is not a bit addressable register. And this is about the transmitter. So next proceed with the reception also. Okay, you need to write a program for receiver also. Okay, so that shall we join again or else can we stop here? We have just 1 minute. Respond me whether we join again for the receiver module or else shall we stop here. I want a poll based on your interest. I can continue. Please respond. Whether yes or no, you type it in the chat window. You want to join again for the receiver module or else we will stop here. Please respond. I need your input.